The last topic regarding to the internal combustion engine, it is called formulas. So the formulas, it is very much important during the numericals, and in the formulas first we need to understand some of the basic concepts like what is meant by the mean effective pressure, indicated power, brake power, frictional power, mechanical efficiency, thermal efficiency and specific fuel consumption. Very first important thing, it is called what is meant by the mean effective pressure. So mean effective pressure, it is nothing but a mean or average pressure acting on the piston during the power stroke. So what happens during the power stroke? During the power stroke, inlet and exhaust valves are closed, and at the beginning of the power stroke, the air fuel mixture catches the fire from the spark plug, hence power is going to develop. So due to the development of the power, so here the fuel is going to completely burn, hence high pressure and high temperature of burnt gases exerts the force on the piston, and that pushes the piston from top dead center to the bottom dead center. And how much amount of pressure is going to exert on the piston, that is called as the mean effective pressure. So in order to know what is meant by the mean effective pressure, we need to conduct the one experiment with the help of the indicator diagram. So in that indicator diagram, for the development of the indicator diagram, we are going to use the spring, and that spring, it is connected to the one needle. Okay, and the value of the spring, it is called it as the S, and small l, it is called it as the length of the indicator diagram, and small a, it is called it as the area of the indicator diagram. And the formula what we are going to use for the calculation of the mean effective pressure, it is called S into A by L, and the unit for the mean effective pressure is bar, and mean effective pressure, it is denoted by capital P suffix M. So then what is mean by the S? S, it is nothing but the spring value of the spring used in the indicator diagram, and it is denoted by bar per centimeter. Then what about the L? L, it is nothing but the length of the indicator diagram in centimeter, and A, it is called it as the area of the indicator diagram in centimeter square. Okay, so apply here bar per centimeter into centimeter square divided by centimeter. Everything is cancelled out, so only left out, it is called bar, and the mean effective pressure, it is expressed in bar, and it is denoted by capital P suffix M, that is called PM. So this is regarding to the mean effective pressure. So then second one, what is mean by the indicated power? So indicated power, it is nothing but the total power developed inside the engine cylinder due to the combustion of the fuel, that is called it as the indicated power. So then how to calculate the indicated power? Indicated power, it is usually denoted by IP. Then the unit of the indicated power, obviously in kilowatts or watts or kilojoules. Okay, so here IP is equal to power produced by the piston per cycle into number of cycles per minute. We all know that what is meant by the power. So power is nothing but work by time, right? That's why we have taken here power produced by the piston per cycle into number of cycles per minute we have considered, and here power produced by the piston per cycle, I can write it as work done by the piston per cycle. So we know that what is meant by the work. Work, it is nothing but force into displacement. So what is meant by the displacement? So displacement, it is nothing but stroke length. That means here the piston is travel from TDC to BDC, that is called it as the displacement, that is called stroke length. And we can also take force, it is nothing but pressure into area into L. So here pressure, it is nothing but mean effective pressure, then I can take it as PM. A, it is nothing but area of the cylinder, and L, it is called stroke length. Okay, so here work produced by the piston, I will directly take it as PM into A into L, and number of cycles per minute, I will take it as small n, and per minute we are considering that is 60. Okay, so this is regarding with the watts. If you want to take in kilowatts, then it is nothing but PM L into A into small n into 60 into 1000. This is called kilowatts. Okay, so then what is the formula IP for 4-stroke engine. We all know that in case of the 4-stroke engine, the number of cycles is equal to engine crankshaft speed divided by 2. That is, small n is equal to capital N by 2. Therefore, now formula becomes Pm L into A into N by 2 into 60 into 1000 kilowatts. This is the indicated power for 4-stroke engine. Similarly, indicated power for 2-stroke engine, here small n is equal to capital N. Therefore, IP is equal to Pm L into A into N into 60 into 1000. So, this is regarding to the indicated power for 2-stroke engine. Then next one, what is mean by the brake power? So, brake power, it is nothing but it is the net power available at the engine crankshaft, that is called it as the brake power. Then how to measure the brake power? The brake power going to measure by applying the brake at the engine crankshaft. So, in order to know how much amount of brake power is required, we are having the one experimental setup. In the experimental setup, engine crankshaft, it is connected to the dead weight. So, that dead weight, it is having the weight W. By increasing the weight W, the speed of the engine crankshaft is going to reduce it. At what speed, at what weight? So, the engine crankshaft is completely stopped. That will be considered for the calculation of the brake power. Okay. So, what is mean by the brake power? Brake power formula, it is nothing but 2 pi Nt by 60 and unit is again kilowatt. Okay. Then how to calculate the torque? We all know that torque, it is nothing but force into radius, but here we are applying the weight W. Therefore, that is 9.81 into W into R divided by 1000. That is, we are going to obtain in kilonewton per meter. Okay. So, net power available at the engine crankshaft, that is called as the brake power. So, in order to calculate the brake power, we are connecting the engine crankshaft to the dead weight. By increasing the weight, here the engine crankshaft is going to stop, and here T represents the torque developed and R represents the radius of the brake drum. Okay. So, here and the W, it is called as the net weight applied on the brake drum. So, here W in terms of kg. In order to convert kg into Newton, we are multiplying with 9.81, then it will become Newton. Okay. Then by divided by 1000, then it will become kilonewton. Okay. So, once we calculated the torque by knowing the radius of the brake drum and what is the amount of weight applied at the pan, then we are going to know what is meant by the T. Once we know the T, then apply the formula BP is equal to 2 pi Nt by 60. Okay. What is the N? N, it is nothing but engine crankshaft speed, that is in terms of revolution per minute. Last one, what is meant by the frictional power? So, frictional power, it is nothing but it is the difference between indicated power minus brake power, that is also in terms of kilowatt. We all know that whatever the power developed due to the combustion of the fuel, it is going to transfer to the engine crankshaft. But here some of the movable components like piston, crankshaft, connecting rod, these are all available. So, due to the friction between these moving parts, the power is going to lose, and that is called it as the frictional power. And the frictional power, it is nothing but total power developed inside the engine cylinder minus net power available at the engine crankshaft. That is called it as the frictional power, that is IP minus BP is equal to kilowatt. Sorry, IP minus BP. So, and it is expressed in kilowatt. Next one, what is meant by the mechanical efficiency? So, mechanical efficiency, it is nothing but brake power by indicated power into 100, or it is nothing but directly I can write it as BP by IP into 100. This is regarding to the mechanical efficiency. So mechanical efficiency, it is nothing but how much amount of power is available at the engine crankshaft to the how much amount of power is developed due to the combustion of the fuel, that is called it as the mechanical efficiency. And the mechanical efficiency is do not having any unit, because kilowatt and kilowatt is going to cancel out. Therefore mechanical efficiency is nothing but brake power by indicated power. The next it is called thermal efficiency, and the thermal efficiency, it is nothing but power produced divided by heat supplied into 100. For example, if you are considering the brake power, then power produced is nothing but BP, and heat supplied it is MF into CV into 100. Here BP it is called brake power, and that is in terms of kilowatt, and MF it is nothing but mass of the fuel supplied, and that is in terms of the kg, and CV it is nothing but calorific value, and the calorific value it is usually represented by kilojoule per kg. Here kg is going to cancel out, and here kilojoule and kilowatt are remains the same. Therefore brake thermal efficiency is equal to BP MF into CV into 100. Similarly, if you are taking for indicated power, then formula become IP by MF into CV into 100. So this is regarding to the thermal efficiency for brake power as well as the indicated power. So these are some of the main formulas what we are going to use in case of the internal combustion engine. So before going to the numericals, so some of the basic formulas, like what is mean by the mean effective pressure. So mean effective pressure, it is nothing but mean or average pressure acting on the piston during the power stroke, and that is PM is equal to S into A by L. L it is called spring value of the spring used in indicated diagram. Area is called area of the indicated diagram. L it is called length of the indicated diagram, and it is expressed in bar, and it is denoted by PM. Similarly, indicated power, it is nothing but total power produced inside the engine cylinder, and it is denoted by IP and expressed in kilowatt, and that will be is equal to plan by 60 into 100 in terms of kilowatt. So for the 4-stroke engine, number of cycles is equal to capital N by 2, then PMLA into capital N by 2 into 60 by 1000. For 2-stroke engine, number of cycles is equal to engine crankshaft speed, that is PMLA into N by 60 into 1000. For the brake power, net power available at the engine crankshaft, and the formula is 2 pi Nt by 60. So torque is equal to 9.81 into W into R divided by 1000, so that in terms of kilonewton per meter. Then frictional power, it is nothing but IP minus BP. Then mechanical efficiency, it is nothing but, so BP by IP into 100. Then thermal efficiency is nothing but power produced by heat supply. So for brake thermal efficiency, BP by MF into CV into 100, and indicated thermal efficiency, IP is equal to MF by CV into 100. So last one, specific fuel consumption, it is nothing but the rate of fuel consumed divided by power produced into 100. So this is usually represented in kg per kilowatt hour. So this is the unit for specific fuel consumption. So this is regarding to the internal combustion engine. So then we are moving on to the numericals. Hello students, welcome you all for in this session we are discussing about the numericals on internal combustion engine. So in the previous session we discussed about what are the list of formulas we are going to use in case of the internal combustion engine. Under that, first we have discussed indicated power. So here indicated power, it is nothing but it is the total amount of power produced inside the engine cylinder, it is called as the indicated power, and that will be is equal to plan by 60 into 1000 and unit in kilowatts. Then brake power, that means the total power available at the engine crankshaft, that is called as the brake power, and that will be is equal to 2 pi Nt by 60 in kilowatts. Then torque developed, it is 9.81 into W into R divided by 1000 in kilonewton meter. Here W it is called effective load and R it is called effective radius of the brake drum. Then mechanical efficiency, it is a ratio of brake power by indicated power into 100. Then indicated thermal efficiency, it is nothing but power developed divided by heat supplied, and for the indicated thermal efficiency, power developed, it is called indicated power, and the brake thermal efficiency, it is called BP by MF into CV. And the one more formula, it is called mean effective pressure, and that will be is equal to S into A by L in bar. So these are the some of the formulas what we are going to use in case of the numericals on internal combustion engine. So under that very first problem, it is called in a 4-stroke internal combustion engine running at 450 rpm as a bore diameter of 100 mm and stroke length of 120 mm, and indicated diagram details are here area of the indicated diagram 4 cm square and the length of the indicated diagram 6.5 cm, and spring value of the spring used in the indicated diagram are 10 bar per centimeter. Calculate the indicated power. So in the form in the problem they mentioned it is called 4-stroke IC engine. So we know that IP is equal to PM into L into A into N by 60 into 1000. Here small n is equal to N by 2 for 4-stroke engine. Therefore, the formula becomes PM into L into A into N by 2 into 60 into 1000. Okay. So what are the data they given? So here engine running at N is equal to 450 rpm, that is N is given. Then area I can calculate, that is pi by 4 into d square, that is pi by 4 into diameter, you have to convert it for meters, that is d is equal to 0.1 meter and L is equal to 0.12 meter. Therefore 0.1 whole square. So calculate the area. Then area we know, L we know, but PM we need to calculate. So what is the formula for PM? We know that PM is equal to S into A by L. Okay. So what is the value of S? S, it is nothing but 10. Area, it is nothing but 4, and L, it is 6.5. So consider the unit also. Here bar per centimeter for the S, and area centimeter square, and the length centimeter square get cancelled, that is 40 by 6.5. Okay. So here 40 by 6.5, that will be is equal to 6.15 bar. Okay, now we already know what is the PM, then substitute the values, but calculate the area here, that is 0.1 square into pi divided by 4, that is 0.0078 meter square. Substitute here, calculate the IP, that is 6.15 bar, that is nothing but 6.5 into 10 to the power of 5. Then what is the length? 0.12, area 0.078, N, it is 450 rpm divided by 2 into 60 into 1000. So after the simplification, calculate the IP, that is 6.15 into 10 to the power of 5 plus 0.12 into 0.078 into 450. So answer become here 2590380 for numericals divided by 2 into 60 into 1000, that is 1,20,000. So calculate the IP. So we got the IP value, it is 21.5 kilowatt. Okay. So according to this problem, here indicated power we need to calculate, that is PM into LAN. Here PM is called main effective pressure, L is the length of this stroke length, area is called as the area of this piston or area of the cylinder, and N it is called number of cycles per minute, and here for the 4-stroke engine number of cycles per minute is equal to crankshaft speed divided by 2, because power developed in every alternate revolutions of the crankshaft, then formula becomes PM LA into N by 2 into 60 into 1000. So first we need to calculate the mean effective pressure, that is S into A by L. Here the S it is called spring value of the spring used in the indicator diagram, that is 10 bar per centimeter, and area it is called area of the indicator diagram, that is 4 centimeter square, and L it is called length of the indicator diagram, 6.5 centimeter. It is everything available in centimeter itself, then no need to convert it for meters, then directly substitute and get the value of mean effective pressure in terms of bar. So substitute the PM in the indicated in the indicated power formula and get the indicated power value, that is 21.5 kilowatts. So this is the numericals 1. So next it is called numerical 2. Observe here the 4-stroke single cylinder engine of 250 millimeter cylinder dia. So that means here diameter is equal to 250 millimeter and this will become 0.25 meter, and the area become pi by 4 into 0.25, substitute and get the value of the area. Then it has the stroke length, L is equal to 400 millimeter, and that will be is equal to 0.4 meters. And then here piston speed, here we know that the average piston speed formula 2ln meter per minute, but here they given in terms of meter per second, then 2ln divided by 60, it will become meter per second, and that will be is equal to 8 meter per second. Okay, then if the engine develops, they have given the indicated power, that is 50 kilowatts. Calculate the mean effective pressure, that means PM, and the crankshaft speed. Here they are asking for 4-stroke single cylinder engine. So again, so indicated power formula, it is nothing but IP is equal to PM L into A into N by 60 into 1000, but for 4-stroke engine small n is equal to capital N divided by 2. Therefore, IP is equal to PM L into A into capital N divided by 2 into 60 into 1000. Observe here, but in this problem they are asking about the crankshaft speed. So in order to know the crankshaft speed, first we have to use the average piston speed. We know that 2ln divided by 60 is equal to 8. So from here we know what is the value of the stroke length. So from here I can calculate the crankshaft speed. So that is N is equal to 8 into 60 divided by 2 into L. 8 into 60 by 2 into, what is the value of L? L it is 0.4. That is 480 divided by 0.8, and this will be is equal to 600 rpm. So now I know what is the value of IP. PM need to be determined. I know the value of L, area I know, N I know. I need to calculate the PM. PM is equal to IP into 2 into 60 into 1000 divided by L into A into N. So calculate the area here, that is 0.25 whole square into pi divided by 4, that is 0.049. Substitute all the values here. IP is called 50, 2 into 60 into 1000. What is the value of L? 0.4, area 0.049 and N 600 RPM. So first solve the numerator and the denominator, that is 50 into 2 into 60 into 1000. So that is 60 into 10 to the power of 5. So in the denominator 0.4 into 0. So that is 11.6. So PM is equal to 5.10 into 10 to the power of 5 Newton per meter square. RPM is equal to 5.12 bar. So this is the mean effective pressure. So in this problem they asked, so what is the mean effective pressure and the crankshaft speed? So in the average piston speed it is nothing but here the speed at which piston moves from TDC to BDC, it is called average piston speed, and that will be equal to ln meter per minute. But in the problem they are given the piston speed in terms of meter per second, therefore 2 ln divided by 60, that will become 8 meter per second. Substitute the values and get the crankshaft speed, that is 600 RPM. So now substitute the 600 RPM in the formula of indicated power and calculate the mean effective pressure, and that will be equal to 5.12 bar. Welcome back. So the next problem regarding to the calculation of the brake power. During the experiment for the calculation of the brake power, so the following readings were taken. Okay, the following readings were taken on the 4-stroke IC engine. Here the diameter of the brake drum, it is 1.5 meter. So this is the brake drum. So the diameter of the brake drum, it is called 1.5 meter. Then diameter of the rope, so here the diameter of the rope, it is 10 millimeter, and then the spring balancer reading, it is 5 kg, that is S 5 kg, and the load suspended on the brake drum, that is 100 kg, that is capital L, and the crankshaft speed, it is 200 RPM. Determine brake power. We know that the formula for the calculation of the brake power, that is 2 pi nt by 60. Okay, so in this formula we need to calculate what is the torque. Okay, we know that what is mean by the torque. So torque is equal to W into R into 9.81 divided by 1000 in kilonewton meter. But for the torque calculation, I need to know what is mean by the W. The W, it is called effective load, and R, it is called effective radius. Okay, so first of all, what is mean by the brake power? So brake power, it is nothing but here the total power available at the engine crankshaft, that is called as the brake power. So then how to calculate the brake power? So brake power can be calculated by applying the brake at the engine crankshaft. So here the engine crankshaft, it is located to the brake drum, and so in order to determine how much amount of power can be delivered at the engine crankshaft, now we are completely winding up the brake drum to the rope, and the rope, it is connected to the upper side to the spring balancer reading, and itself is having the self weight of 5 kg, and that is considered as S is equal to 5 kg. Now I am applying the some amount of weight at the pan in order to reduce the speed of the brake drum. At what weight? Here the diameter of the brake drum, it is going to stop, that is called it as the final weight. Okay, so here the final weight the brake drum is going to stop, it is called as the 100 kg. But here for the effective load I need to calculate W is equal to L minus S. That means initial spring balancer reading must be removed. Okay, so here 100 minus 5, that will be is equal to 95 kg, and here the rope, it is winding up to the diameter of the brake drum. Therefore effective diameter is equal to now dr by 2, it is nothing but diameter of the brake drum, and db it is called diameter of the rope. Okay, so that is 1.5 divided by 2 plus, here they have given it is 10 millimeter, so you need to take only 0.01, that is 10 by 1000, that is 0.01, so that is 0.01 divided by 2. So effective radius we need to take so that is 0.755. So now substitute the values in the torque, that is W is 95 kg, R it is 0.755 into 9.81 divided by 1000, and torque is equal to, calculate, that is 0.7036 kilonewton meter. Now substitute the value of torque in brake power, that is BP is equal to 2 pi, what is the value of N, that is 200 rpm into 0.7036 divided by 60. So BP is equal to 14.73 kilowatt. Okay, so in the calculation of the brake power, first we need to calculate the torque. For the calculation of the torque, we have the formula W into R into 9.81 by 1000. What is mean by the W? W, it is called effective load. Effective load, it is nothing but here the load suspended on the brake drum and then with minus spring balancer reading. So, and the effective radius, it is called diameter of the brake drum as well as the diameter of the rope should be added together, so that effective radius R is equal to 0.755. So by knowing the W and R, we are calculating the torque, that is 0.7036 kilonewton meter, and the brake power, it is 14.73 kilowatt. So next it is called find the indicated power of 4-stroke petrol engine of swept volume. Here the swept volume and stroke volume are one and the same, and that is will be is equal to 6 liters. So 6 liters means 6 into 10 to the power of minus 3 meter cube. Okay, and the engine running at 1000 rpm, and the mean effective pressure PM, it is 600 kilonewton per meter square. That will be is equal to 600 into 10 to the power of 3 Newton per meter square. Here I need to calculate the indicated power of 4-stroke engine, that is PM into L into A into N divided by 2 into 60 into 1000 for 4-stroke engine. Okay, so here I need to calculate what is mean by the indicated power. We know that what is mean by the PM and we know that N, but what is mean by the L into A? So L into A, it is nothing but stroke volume, and that is directly given, that is called 6 into 10 to the power of minus 3. Substitute here, IP is equal to 600 into 10 to the power of 3, and value of L is equal to L into A is equal to 6 into 10 to the power of minus 3, and crankshaft speed, it is 1000 rpm divided by 2 into 60 into 1000. So directly 1000 and 1000 get cancelled, and 10 to the power of 3 and 10 to the power of minus 3 is also get cancelled. Then IP is equal to 600 into 6 divided by 2 into 60. Here 60 ones are 60 tens are, that is 60 by 2, that is IP is equal to 30 kilowatt. Okay, so here very important one, it is called what is meant by the swept volume or a stroke volume. So it is nothing but volume covered by the piston when it is moved from TDC to BDC, it is called it as the stroke volume, and that is equal to 6 liters. 6 liters, it is nothing but 6 by 1000, and we are taken 6 into 10 to the power of minus 3 into meter cube. So here L into A, it is called 6 into 10 to the power of minus 3. Substitute the values and calculate the IP, and that will be is equal to 30 kilowatts. The fifth problem regarding to the internal combustion engine, it is called here a 4-stroke petrol engine of 1000 millimeter bore diameter and 150 millimeter stroke length consumes 1 kg of fuel per hour. That is MF is equal to 1 kg per hour, and PM it is called 7 bar, and indicated thermal efficiency it is 30%. So, and they also given calorific value, it is 40 into 10 to the power of 3 kilojoule per kg. So find crankshaft speed. We know that here the 4-stroke petrol engine. So that is here the formula for indicated power, it is nothing but PM into L into A into N divided by 2 into 60 into 1000. Okay, so I need to calculate what is the crankshaft speed. So cross multiply IP into 2 into 60 into 1000 divided by PM into L into A. Okay, so here I need to calculate what is the area. So area is equal to pi by 4 into d square. So pi by 4, what is the value of diameter? So here as 100 millimeter bore, that is 0.1 whole square, it is area is equal to, calculate 0.1 square into pi divided by 4, that is 0.078 meter square. Okay, then what about the L? The stroke length they have given 150 millimeter, that is 0.15 meter. Okay, so we know what is meant by the L, what is meant by the area, and what is meant by the PM, that is 7 bar, that is 7 into 10 to the power of 5, but I don't know what is the value of indicated power. So how to calculate the indicated power? So here they have given indicated thermal efficiency. So what is the formula for indicated thermal efficiency? Observe here, for the indicated thermal efficiency, formula is IP by MF into CV into 100. Okay, so IP by MF into CV into 100. Here call it as equation number 1 for crankshaft speed, and here for the IP cross multiply indicated thermal efficiency into MF into CV divided by 100. So what is meant by the indicated thermal efficiency? It is 30%. Substitute. Okay, what is the value of MF? MF it is they have given in terms of 1 kg per hour. So MF it is 1 kg per hour, that means convert it for seconds, 1 divided by 3600, that will be equal to 1 divided by 3600, that is 2.78 into 10 to the power of minus 3 MF. Substitute the value of MF, 30 into 2.78 into 10 to the power of minus 3, and CV they have given, that is 40 into 10 to the power of 3 into 100, that is IP is equal to 3.33 kilowatts. So substitute the value of IP in equation number 1, that is N is equal to 3.33 into 2 into 60 into 1000 divided by PM, it is 7 into 10 to the power of 5 into L, that is 0.15, and area it is 0.078. So after the simplification, speed is equal to 484.80 RPM. Okay, so this is regarding to the calculation of crankshaft speed and the indicated power with the help of the indicated thermal efficiency. So indicated thermal efficiency is equal to IP by MF into CV into 100. Your mass of the fuel is given 1 kg per hour, that is 1 divided by 3600, that will be equal to 2.78 into 10 to the power of minus 3. Then once you got the MF, calculate the IP, that is 3.33 kilowatts. Then calculate the crankshaft speed by substituting the value of IP in equation number 1, we get 484.80 RPM. So the next problem it is called here, the gas engine working on 4-stroke cycle has 250 millimeter dia, that is 0.25 meter, and the length it is called 0.45 meters and running at 180 RPM. And here the mechanical efficiency they have given, that is 80%, and PM it is 0.65 into 10 to the power of 6 Newton per meter square. Find IP, BP and FP. Okay, so initially we need to calculate the IP value. So here IP for 4-stroke engine, that will be equal to PM into L into A into N divided by 2 into 60 into 1000. Okay, here we know what is mean by the PM, what is mean by the L, what is mean by the area, and everything. Calculate the IP. So area is equal to 0.25 whole square into pi divided by 4, that will be equal to 0.049 meter square. PM is 0.65 into 10 to the power of 6, and value of L is equal to 0.45, area 0.049, and crankshaft speed it is 180 RPM divided by 2 into 60 into 1000. So the value of IP we need to calculate, that is 21.53 kilowatt. Okay, so next I need to calculate what is the value of BP. For the calculation of BP, we don't need to use the formula 2 pi nt by 60 because we don't know the value of the torque. So because of that we use other formula, that is called mechanical efficiency is equal to BP by IP into 100. Okay, here mechanical efficiency is equal to BP by IP into 100. So here BP is equal to mechanical efficiency into IP divided by 100. So what is the mechanical efficiency they have given? It is 80%. So IP 21.53 divided by 100, and that will be BP is equal to 17.22 kilowatt. So finally I need to calculate FP. FP it is nothing but the difference between IP and BP. Here IP I got, it is 21.53 kilowatt minus 17.22 kilowatt. Therefore FP is equal to 21.53 minus 17.22, that is 4.3 kilowatt. Okay, so this is regarding to the sixth problem. Here gas engine working on 4-stroke cycle has 250 millimeter dia and stroke length 450 mm and running at 180 rpm. Here I need to calculate what is the value of IP for 4-stroke engine. It is PM L into A into N by 2 into 60 into 1000. Here IP is equal to 0.65 into 10 to the power of 6, and calculate the IP, that is after the substitution and the simplification, IP we got it is 21.53 kilowatt. Similarly For the calculation of BP, we need to use the formula called mechanical efficiency, that is BP by IP into 100. For the BP, substitute the values, mechanical efficiency into IP by 100, that is we got 17.22 kilowatts. Then the frictional power, it is nothing but it is the difference between indicated power and the brake power, and we got it is 4.3 kilowatts. So this is regarding to the calculation of IP, BP and FP.